Thank you. Thank you, everyone. How are you doing today? Okay, my name is Adedayo. I'm from Nigeria. It's been a pleasure to be in this talk today. Today, I'm going to be talking to us about test-driven infrastructure. But before I begin, I would like to I would like to take a little bit to talk about myself and my country. Yeah. So can we all see my screen, man? Can you all see my screen? Awesome. Okay. So we'll be talking about test-driven infrastructure using Serverspec, platform, and CPCI. But like I said before we begin, we'll take a little bit to talk about Nigeria. I'm pretty sure some of us have some misconception about Nigeria, so I'm just going to take 2 minutes of our time to talk about Nigeria. This is my beautiful country. Uh, we've been it's been a lot of puzzles facing different countries, having to talk in different countries because we face a lot of bias because people think Nigerians are all scammers, right? So I just want to take a little bit of our time to just tell us some interesting things about Nigeria. So we have a population of 190 million, and we have our tech ecosystem is currently worth around 400 billion, right? And then we have different people engineering in the tech system in Nigeria. And so far in Nigeria, we have different tech jobs that are currently taking place. So, and then we have different startups that are even taking hold of the Nigerian tech ecosystem currently. We have startups like Terragon, we have startups like Andela. All these startups are really doing well in Nigeria. So we have different tech ecosystem in Nigeria, and our tech ecosystem here in Nigeria is very, very vast. So I hope we will just, take that bias off and get to know the more interesting things about Nigeria. Yeah. So a little bit about myself. So I started my career as a software engineer. I worked as a software engineer for 4 years before I moved on to working as a DevOps and site reliability engineer. And then from there, I work as I do DevOps Nigeria. So DevOps Nigeria is basically a platform where we mentor DevOps people that are interested in doing DevOps, and then we also um, um, expand the DevOps community in Nigeria. So that's basically all the things we do in DevOps. And then I currently work for a blockchain company where I'm responsible for scaling their infrastructure and therefore ensuring fast delivery of software processes and applications. So are we ready for this talk? So before I begin, I would like to know my audience, I would like to get to know some of the things we do. So currently, please, by show of hands, how many developers are in the house? What about testers? How many developers are currently in the audience? Oh, okay, awesome. What about testers? Testers, awesome, awesome. What about DevOps engineers? Oh, wow, nice. So it means everybody would have a full grasp of what I'll be talking about. So today, part of the things I'll be talking about is infrastructure as code. I'll be talking also about the test-driven development and how it relates to test-driven infrastructure. Then I will take us through different test-driven infrastructure tools that are being used. And then will get to know how to use some of these tools like Serverspec and Kitchen CI. They will take a little break to write test suite in Serverspec so we can actually see how it is being done. And then if our time permits, we can now look at how to integrate this test into our Jenkins or any CI/CD pipeline that we currently have. So by the end of this talk, we should be able to have a full understanding of what test-driven infrastructure is, and then we will be able to run and use server specs from the command line, and also be able to set up different server spec test suites across different resources. We'll be able to see as developers, as testers, as DevOps engineers, how we can apply these test suites to our different configurations. So yeah, so I'm sure we all know this. We all know this guy G4. So I just want to tell a bit story about how we do things, how we deploy applications to our different environments. Back in the days, we have we used to have someone like Guilfoyle. This is a sysadmin. So what this guy does is this guy is responsible for setting up servers. This guy is responsible for application security. This guy is responsible for deploying applications. This was the way we do things, right? And then after we have this guy, we call him the sysadmin. Then after G4, we have another guy that's called developer, right? And then we have another guy that's called tester. So this was how we do things back in the days, maybe like 5, 6, 10 years ago. And then over the time, we realized that this is not improving our software development cycle. So we decided to do something. We decided to start writing instructions for how to set up our applications. Meaning, let's say, for example, our task involves a PHP, a MySQL, and probably an Apache, right? For any developer that wants to come on board, or for every time that we want to deploy this application to production, we need our sysadmin guy to actually install PHP, to set up the server, to install Nginx, to install fast CGI, and make sure everything is working together. But now, because there were a problem of trying to track the sysadmin and not relying on the sysadmin, so the developers thought about it that why don't you write a setup instruction, something like this, that will guide anybody that wants to deploy an application or that wants to set up an application or any dependencies. It guides them through how to do it. So this was the solution then. This was what was working. So writing it, so we call it a README now, right? Where you just write a README and just you have your set of instructions. So you can just look at this README where we have the apt-get update, install all your dependencies. So usually when you follow this, it works, right? This was the way we were doing it. And then over the time, we realized that, okay, this is not scaling for us. This is still not working as much as we want it to work. Our software development cycle is still not fast enough. So we decided to start writing bash script, something like this. I'm sure we are familiar with this, right? So we decided to start writing bash script. So what this means is, so for every of our version control code base, we always have something like install.sh or setup.sh. This file is being deployed, is being committed as part of our code base to help anybody that wants to deploy this application set up properly. So all we just tell the anybody that wants to deploy it to do is just run sh install.sh, right? And then this automatically install everything that is needed to install. Yeah, can we all relate to this story? Can we all relate to this story? Okay, all right. And then after a while, so the question is, can we all relate to the story? Can we all relate to the story? Okay. Okay. Then so after having this set of instructions, right, we have this setup.sh. But then, even though we have this setup.sh, we still have a problem. We have the problem of inconsistency, meaning the way a developer runs code or writes bash script is not the same way another developer will write bash script. Meaning we start having different test configurations across board. We start having different test cases. We start having different installation instructions. So in order to curb that, the idea of infrastructure as code came about. Past 3, 5 years, this is the way for us. This is what has been working for us. Infrastructure as code. Now, infrastructure as code simply says we apply the same set of rules that is being used in software development, and then we apply them to infrastructure provisioning. Do you get that? Do you get that? Yes, thank you. I just want to be sure everybody is following. Like I said, infrastructure as code now says we apply the same set of instructions, the same set of processes that we apply to software development. We apply it to infrastructure provisioning and also to infrastructure orchestration. Now, what this part now means, so let me just like I defined earlier, if Morris defined it as an approach to infrastructure automation based on practices of software development, it just emphasizes three basic things: consistency, repeatability, and availability. So with this, we are able to ensure that our system runs the same way all through. Now, for infrastructure as code follows a set of process, right? Just like our software development process follow set of processes, right? So this process infrastructure as code follow is you design your architecture or your infrastructure, you design it first, and then you write the code to make all these things happen. Then when you write the code, then you now test this code to make sure everything is working fine, right? This was the way infrastructure as code works. This is the way we've been working with it, and it works well for us so far. But before I even come to why it's not the current limitations we have with infrastructure as code, let us take a step to look at different tools that are being used in infrastructure as code. So for infrastructure as code, so we have the chef, we have the puppet. These are all called configuration management tools, right? So we have Terraform, we have Ansible. How many of us have used all these tools before? Okay. So I'm sure most of us are familiar with all these tools. For most of us, these tools have helped us in orchestrating our infrastructures. These tools have helped us in automating deployment across different environments, whether you are using a Windows machine or you are using a Ubuntu or a CentOS machine. With any of these tools, you can automate your processes and get things done. So what are the problems infrastructure as code has helped us solve? Like I said, we have been able to move from manually setting up server to automatically writing configuration code that actually deploys and sets up all the servers that we want. And also, just imagine when you manually configure a server, it means that you are not keeping record of the state or the changes that are being made, right? But with infrastructure as code, you're able to keep track of all the changes that are being made. So it means you now have a version control, you are now able to track change, and you are now able to even make corrections based on maybe error or misalignment that have been done. And also, another good thing about infrastructure as code is we are now able to reuse our code. That means I don't have to come again and write another script or do the same thing I did to install Nginx or Apache. I can now use that same code, use it across board. I can use it, my team member can use it, and everybody can use it and be happy. And there is this common problem for me personally. The problem pisses me off, and that's the problem of it works on my local machine, but it's not working on production. How do we get rid of this problem? That is where infrastructure as code comes in. So I'm sure with infrastructure as code, we're able to get rid of this problem of it works on my machine, it doesn't work on production. Now, however, the infrastructure as code community tends to see that they are working on stuff to make things better. So what the infrastructure as code community wants to make sure we have in our development process is to make sure that changes to the system are routine, meaning that any change that is made to the system is routine, is orchestrated, and is being known. And then we are able to also eliminate long, boring, repetitive tasks from our pipeline. So you can imagine every time you have to come and restart Nginx when something is bad, or every time you have to come and restart your Docker engine, or you come and restart your test server engine, maybe your Jenkins. But with infrastructure as code, you can always write your code to repeat, to eliminate long, repetitive tasks. Then you can easily define and provision any resources you want. Any resources you want. Maybe you want to provision CentOS, you can provision anything you want. And then this has also helped us to give room for continuous improvement, right? So it means that you can improve your infrastructure, you can continually deliver good products, good product to your teams, and you can continually make sure that your service and applications are running fine. Now, as good as infrastructure as code is for us currently, we have some limitations to infrastructure as code. And that limitation is in manual correctness. So it means that if you take a step back and we look at the way infrastructure as code is set, it means, remember we said you design first, then you code, you design first, then you write your code, and then you test, right? Now, what this problem causes for us is, for every time we make a change to our version control and push our version control, we have to manually test that everything is working fine. Let me put this in context for us. Let's say we have a Terraform module that SSH into a server, install Apache, and install MySQL, install MongoDB. Now, when this Terraform module is done, we have to now go back to our terminal and SSH to these different servers manually to make sure that indeed Mongo is running, indeed MySQL is running. This set of manual correctness has created delay for us in our development process. So because of that, we thought about what can we do? What can we do to improve this process? What can we do to make sure that we are not, for every of the infrastructure that we provision, we are getting the results that we expect without having to enter the machine or the environment that we are. And then another problem that we have is configuration drift, meaning the different configs are being written everywhere, right? Even as much as everybody is writing the same configuration code, but then there are drifts to it because we are not certain about the kind of environment that is being set. So for us as infrastructure and site reliability engineers, we want to be sure that our infrastructure is the same as we expect it to be. So the question I want to ask is, how do you make sure that your environment behaves exactly the same way you want it to behave. I won't expect us to answer the question, but the simple answer to that is test-driven infrastructure. Now, test-driven infrastructure says it helps us test our environment, our applications, our servers, our services right before we even write the code to even do all these things. It means that it tests everything to make sure that everything is working perfectly. Now, I'm sure as many of us are developers, we are familiar with the concept of test-driven development, right? So, how many of us are familiar with test-driven development? Okay. So, can someone tell me what test-driven development simply means? Anyone from the audience? Yeah, thank you. That demands to the left of, yeah. Yes, yes. I think he wants to help. Anyone that is willing to help. Okay, it's fine if you don't have anybody to help. So okay, okay, it's fine. So for test-driven development, for most of us are developers, test-driven development is saying that you write your failing test first, then when you then you run the test. When you run the test, of course, it to return fail for all of your conditions. Now, for all of those conditions that fail, you now come back and write a the code that will make them pass. So when you write the code that will make them pass, you run the test again, and then this time around, the test pass because you've written the code in a way to make the test pass. You understand that? Okay. So now, what we are now doing in test-driven infrastructure is to apply that same technique to writing infrastructure code. Now, instead of the normal way of test-driven development where we have you design your code and then you write your code and then you test. Now, in test-driven infrastructure, we are moving that test part to come before the writing of code. That means before you even write your code at all, you have to come and test your infrastructure and test that everything is working the way it should work. Right. So again, let me repeat again. Test-driven infrastructure is a tenet of software development process that we borrowed that says let us write unit failing unit test first for our infrastructure. Then we write a code to make them pass. And then from our code, we run them. And once we run them, our code now pass. And we are sure that our code is behaving in exactly the same way that it should behave. So why should we adopt the use of test-driven infrastructure? I'm sure some of us will have been thinking, why should we adopt the use of test-driven infrastructure? Now, test-driven infrastructure has helped us solve all of these problems. The first problem is one, we are able to do cross-platform testing, right? I'm sure for some of us that are testers, we've been through different cases where you have to test how your application behaves on a Ubuntu machine and on a Windows machine and maybe on a CentOS machine. But with test-driven infrastructure, you're able to test your infrastructure code across all platforms. You know that for Windows machine, it's behaving the same way as it should on a Ubuntu machine. Another thing Another good thing about it for us is we're able to validate expectations. That means, take for example, if you want Nginx to be running in a machine, we're able to know that Nginx is indeed running right. And then it also gives us extreme confidence in our automation, meaning we're able to know and beat our chest that our infrastructure is running perfectly as well as it should. And then when you're able to beat your chest confidently and say that your infrastructure is running well, it also gives you're able to have that consistency across all board. It means for every of your infrastructure, everything is consistent across board. And then when it comes to time when you want to migrate your services, you can calm down and write the same test before you migrate your services to make sure that this new environment that I want to migrate my to is working perfectly. Now, another tool of this is use is the better infrastructure stability. It still boils down to our infrastructure consistency and everything we've talked about so far. So it means that our downtime reduced drastically. Because in a situation where you have been able to test everything that could possibly fail, you are able to ensure a better infrastructure stability. And then even for that, you're able to know if your application is going to fail. Even if it's going to fail for any reason, you will be able to know early that, oh, this particular guy is going to fail. So you're able to handle this thing properly because you failed even before you in production. You're able to take learnings from that failure and then adjust it accordingly. So just like we said about the cycle of the test-driven development. So for the test infrastructure, this is the cycle for it. So the cycle is just like I explained earlier. You write your failing test, right? So and then when you write your failing test, then you come down and write your code. So your code cannot be maybe a Terraform code or a Chef code or an Ansible configuration. Now, you come down and you write some of these guys, you write your code for all of these test passes, all of these test cases that you've written here. You write the code and make them pass. And then when you run them, the code pass, right? Now, when you run them here, at this point here, where the code pass, you now see that your code pass, then you now start making changes to make sure that everything is working according to your right to the test case that you wrote, right? So what this has been able to do for us is, for all of this process, be able to cycle and iterate in small increments. It means that you can have like 100 test cases, but when you have 100 test cases, you're able to now start writing code to make all of these tests pass one after the other. So it means you can start from maybe the first 10, you write the first 10, then you run it, it pass, then you come down to this place where you refactor your code, and then it pass, and then you follow that cycle until your infrastructure is working in a condition that is perfect for you. Right. So in doing this, the tools that have been used currently to do this currently, just following that same cycle from the previous slide. So for the cycle of writing your failed test or your failing test, that is where Serverspec comes in. We will still come down and talk a little more about Serverspec. But the tool that is used here is Serverspec. So here you use Serverspec to talk about to write your infrastructure test and your automation test. And then when you now want to come down to that part where you want to write the code to make them pass, that is where you come here and write your Terraform config, or maybe your Ansible config, or your chef config, any of these things. So for every time you now write these things, for every of the change you make to them, you refactor it, run the test again, and then you follow that cycle, like I said, until your infrastructure is set. So we have 5 principles of test-driven infrastructure. But before I continue, I want to make sure that we are all following me. Are we all following me? Okay. Are we sure? Are we sure we are all following? Please, if I'm moving too fast, please draw me back. Or if there is anything you don't understand so far, please draw me back. So is there any question you would like to ask so far before I continue? Okay. So for a test-driven infrastructure to be standard and for it to work accordingly, there are five principles that we have to follow. Five principles of test. So these five principles, if we can follow them, it means we are really practicing of test-driven change that you make to your infrastructure. You write them down. Remember from the beginning, the part where we talked about writing a README document that explains how to set up a particular server or how to deploy a particular infrastructure. That document is what we're talking about here. So you document every of your process, right? You document everything. So the time you make changes to your server, you document it. The time you change your Nginx port, you document. And after you have documented it, the next thing you do is to test. So you test that this change that I made is indeed a fact. You test that this indeed is working perfectly and then it's something that you can include into your process. So once you tested, then you now come to the part where you now implement, right? So you implement this set and git control system where you can push your code to, then you version it, and then more code and continually improve on these processes. So you can keep changing and making iterations to your code base, make this work perfectly. So following that same the principle of remember the principle I mentioned, document, test, implement, version, and continuous improvement. So you watch the test, that is the test part, and then you read the code, which is implementation, right? And then you run the test, which is still part of implementation, and then you refactor, which is coming down under versioning and continuous improvement, right? These five principles makes us have a sure stability in our infrastructure because we're able to test our infrastructure right before right before we even deploy our infrastructure. Now, as much as test-driven infrastructure is good for us, as much as this is the best way to ensure that our infrastructure are consistent, there are some ways that if we don't do it right, we won't get our desired results. Right. So in order to get it right and have our desired result, there are some recommendations that I would like to make. So the first thing is just two recommendations actually. And the first thing is it boils down to keeping your test configuration small. Remember, we want to include this test configuration into our continuous integration and continuous deployment pipeline. And in order to avoid long time feedback or the long time running of our continuous integration and deployment pipeline, we need to make sure that our test cases are small and then they are small as possible so that we don't, at the end of the day, start having like 100 tests that would delay the deployment of our application and service because the time your application is meant to use to deploy is being used to test locally. Are we good? So coming back to some of the tools that are used in Red as code, right? A server configuration test for your Windows server or your Unix server or any server. With Serverspec is that tool that is being used for that. And then we also have Kitchen CI. All right. Kitchen CI is a test orchestrator. Kitchen CI is kind of like our Jenkins in our continuous integration and deployment pipeline, right? And then we also have AWS Spec. AWS Spec is another suite tool in test-driven infrastructure because with AWS Spec, for some of us that use AWS, we're able to test that, especially when you use AWS with cloud formation. Right, you're able to test that your cloud is behaving check. So all of these tools, these are four of the most common tools that are being used currently: Serverspec, Test Kitchen, AWS Spec, and then Inspect. Be able to make sure that it's working perfectly. So let me tell you also a little bit about Serverspec. So Serverspec is written based on RSpec, right? And then it's used to test, like I said, test our server configs to make sure that they are working fine. Now, Serverspec has been done in a way that it can work with any cloud formation tools that we want it to work with, like Puppet, Ansible, Terraform, Check. Serverspec can easily work to help us write test cases to make sure that all our configurations are working fine. So why should we use Serverspec? To in, for the most of the reasons why we use Serverspec is like it boils down to most of the reasons why we are doing test-driven infrastructure, which is to validate expectations and then to automate our quality assurance process. So this way we are able to automate our quality assurance process and know that our application is running perfectly as it should across all board, across every scenario. And then we're able to also fail early, right? It still boils back to what you said about TDI. And then we're able to validate our output. And then we're able to also build confidence in our infrastructure. So these are some of the things that test-driven infrastructure has done for us. And with Serverspec, we're able to use Serverspec to actually automate this process and make sure all this process is working fine for us, right? Are we good? So some of the, in case you've been wondering, so how does this apply to me? How do I apply the use of Serverspec? Uh, where does it come in my infrastructure provisioning? So these are the areas where Serverspec can be used. So you can use Serverspec to install all your packages and test that all your package installations are properly installed. Say for example, for some of us that write Python, or and I'm sure some of us feel that issue where you are trying to install a dependency that is meant to work for version 2.7, but is working for version 3.0. So, but with Serverspec, we're able to have a test case for this to make sure that our package installation is working fine. And then command execution. So for every of the command that we want to run on all our servers, we're able to also write test case to make sure that our Serverspec, our infrastructure configuration is working perfectly. And then even when it comes to writing, to checking for running processes and pods, you're able to know that your running process is is working fine. You're able to make sure that your processes and your pods are working perfectly. So that those are part of the good things about server spec. Right. So you can test that port 80 is working perfectly. You can check that Nginx is running. When we come to the place where I'll show you how some of these parts work. And then you can also check for pipe permission. Right. So all of these use cases has been written in our test suitcase, right, to make sure that our infrastructure is properly set up before we even move to deploying our application down to the infrastructure. So exactly. So if you can take a look at, so we can take a look at how it's going to work. So this is a sample server spec config, right? So can we all see this? Can we all see this? Okay. So yeah, you. So I'm almost done. So I'll just round it up now and go through everything. Okay. Okay. So these are the different. So I'll just show us how server spec currently works. So for your test config in server spec, so you just come and describe your service. So let's say you are running a Java server and you want to make sure your Tomcat server is running. You write a config code, something like this, and then you write an application code for it to run like this too. So you can also test for your file to make sure that your file is a file, to make sure that it's owned by the correct user and all of these test cases. So you can just even take a look for from this short demo. So I prepared our aspect so you can see that automatically. And then we want to make sure that the ports are running correctly as they should run. So if you look at it, so this runs for us. So just look at it. So even if you want to run check, you are able to check and see. So just take a look at the demo so you can have a full grasp of what I'm talking about. So we see the part where is running GSQL. Now it's writing the test case to check that the port for MySQL is running. And then once we are done writing our test case, we just run it by typing rake spec. And then you can see that for all of those test cases it has passed. Package should be installed, MySQL should be installed, Shell should be installed. And then for every of the things that will fail, everything also fails early and we're able to know what fails and move forward with it. Right. So in order not to waste our time too much, I will also come to tell us a bit about Kitchen CI. So Kitchen CI, like I said, is a test orchestration tool. So imagine when you want to use Kitchen CI, you want to use Serverspec with your Terraform module, with your Docker engine. With Kitchen CI, you can actually write a simple config that orchestrates all these processes all through. So, like I said, it's a test orchestrator. It was written from the chess community. And then with Kitchen CI, you can actually specify different drivers. So you can, Kitchen CI works with Amazon driver, Docker, Rackspace. Google engine, your engine, or the test. Yeah. Then you can also define your provisioners too, maybe your Terraform or your Chef or your Sourcepack, and then you can describe your test suite. So this now comes to using Serverspec, where the Serverspec that we are using, and then we're able to describe our test suite, and then we're able to work with it. And then the last part of this is the AWS spec, right? AWS, most of us are familiar with AWS. You know that when you write your Terraform config, right, or your CloudFormation config, you want to make sure that the instance that you have provisioned is indeed running. So this is a sample test suite for AWS. So you see that you can write text that, okay, for this physical machine that provisioned, it should be running. Then the instance ID should be this. It should have security group of this name. So you're able to actually verify that everything is working the way it should work. So yeah, so this is everything that has to do with test-driven infrastructure. I believe at the end of this talk, you'll be able to go back to your drawing board and start implementing test-driven infrastructure, right? So thank you everyone.